Okay, so here's our equation, and remember the first thing we want to do when we're working with a system of equation that's a 3 by 3, you want to number your equations. So here I go and I number my equations. The next thing you want to do is look at the equation and see what is good to try to cancel. That being said, they need to be opposite in sign, so the variables need to be opposite in sign and the same coefficient to cancel. So take a look. Okay, so for me, what I see is that my x's, if you look at equation 1 and 2, you can see that the x's are both 3's, coefficient of 3, and one is positive, one is negative. So I'm going to pair those two up. So to the side here, I am going to rewrite the equation so I can use elimination to cancel out a variable. So it looks like my x's cancel, and then I have 2 plus 4y, which is going to be 6y, negative z plus 5z, that's plus 4z, positive 4z. 8 plus negative 14 is going to give me, let's see, 8 plus negative 14, negative 6. And so this is going to be equation 4. So over here, I'm going to write this as equation 4. Now let's pair up another 2. Remember, we can't use 1 and 2 anymore, so we have to pair up a different 2 equations. So perhaps something that is opposite in signs. Or we could pair up equation 1 and let's see here. We have some options. Maybe equation 1 and 2. Sorry, not 1, 2, 2 and 3. So this is eventually will be equation 5. So if I pair up equation 2 and 3, just going to rewrite their equation here so we can look. 5z equals negative 14. Equation 3 is x minus 3y plus 4z equals negative 14. So taking a look at this, it looks like our x's are both opposite in sign, which is good, but this x here, the coefficient is a 1. So if I want to cancel with my top x, this negative 3x, I have to multiply this x by a positive 3. So that's what I'm going to do here. I'm going to multiply the bottom equation by positive 3. But if I do that, remember, you have to multiply each term in that equation by positive 3. So down here below, I'm going to copy and paste equation 2 because I didn't do anything to that one. So I'm just going to bring it down. So negative, ooh, that's a bad 3. Negative 3x plus 4y plus 5z equals negative 14. And then we have 3 times x minus 3 times y, which is 9y. We have 3 times 4z, which is 12z. Then we have 3 times negative 14. Ooh, what is that going to be? That's going to be negative 42, I believe. Let me double check that with a calculator. So we have negative 14 times 3, yes, that is negative 42. So adding these two equations, oh, maybe I should do that in blue so I can keep it coordinated. The x's cancel out, which is good. So 4y plus negative 9y, that's negative 5y, plus 5 plus 12z, which is 17z, equals negative 14 plus negative 42. They're both negative, so when you add these together, you should get a negative 56. And this is equation 5. Once you get equation 5 and 4, that's when you pair up those two equations. So up here, I'm going to rewrite what equation 4 and 5 are. And we're going to take a look and see what cancels. Now, when looking at this, the only thing that's opposite in signs is your y's, right? So in this case, they're both different in coefficients, and one's a 6 and the other one's a 5, a negative 5. So what I have to do is find like a common multiple. So what's in common in 6 and 5 is that they can both make 30, right? Some number can multiply to 6 to become 30, and some number that can multiply to 5 will make 30. So I just have to figure out what that number is. Well, for 6, if I multiply the equation, the 6 by a 5, I can get a 30 for the y. So in this case, I'm multiplying the top equation by 5. And the bottom equation, I'm multiplying by 6. So working this out here, we have 5 times 6, which is 30y. 5 times 4, which is 20z, equals 5 times negative 6, which is negative 30. Then we have 6 times negative 5y, so that's negative 30y. 6 times 17, let's take a look on a calculator. 6 times 17 is 102z equals, 6 times negative 56. Negative 56 times 6 is negative 336. So in this case, my y's cancel. 20 plus 10, I'm sorry, not 10. 20 plus 102z is 122z. Equals negative 30 plus negative 336 is negative 366. So when I divide these two by 122 to try to get z by itself, so the 122 cancel, z is now equal to negative 3. Because negative 366 divided by 122 is negative 3. So now I finally have z. And so what I'm going to do is try to figure out the next variable. So remember, the next step is to try to plug it in to one of the equations, 4 or 5. So I'm going to choose equation 4 to plug my z in. So up here, equation 4 is 6y plus 4z equals negative 6. And so my z is negative 3. So looking at this problem here, 6y is kept by itself, but 4 times 3, negative 3 is negative 12 minus 6. So I need to add both sides by 12. 6y is brought down, the 12s cancel. Negative 6 plus 12, that's a positive 6. Then I divide both sides by 6. 6 cancel. So y is equal to 1. Now that I've solved for y, so now you have two variables, you want to now plug it into either equation 1, 2, or 3. So I'm going to go ahead and plug it to equation 1. It doesn't matter as long as it's the first 3. So to the side here, maybe I'll do it in black. So my equation 1 is 3x plus 2y minus z equals 8. So let's zoom into that real quick. So my x is the thing that I haven't solved. So I'm just going to bring down 3x. 2 in this case is, y in this case is 1, so plug in 1. And z is -3 equals 8. So working this out, we have 3x plus 2 times 1, which is 2. 2 negatives make a positive, so that's a +3 or plus 3 equals 8. So let's simplify this equation. You can see that we have two numbers here. So this is going to be 3x plus 5 equals 8. I need to get x by itself, so I need to move over my 5 by subtracting. The 3x drops down. The 5's cancel. 8 minus 5 gives me 3. And then I need to divide both sides by 3 to get x by itself. So x is equal to 1. Now that I finally have all three variables, I'm going to write it as a intersection or coordinate. So x goes first, so that's 1, y next, which is 1, and z last, -3. So we have one solution because we have one coordinate. So there's one intersection. And there we have it. That is our solution. Let's zoom out to kind of see all our work, but there it is. I hope that helped.